everyone, welcome back to the channel Math Learning with Shobita. Today we will discuss a question from real analysis which is asked in the Rayachur University Assistant Professor examination. The question: which of the following continuous function f from 0 to infinity, if from the interval 0 to infinity to r can be extended to a continuous function on the half closed and half open interval 0 to infinity? Option 1, f of x equal to sine 1 by x. Option 2, f of x equal to 1 minus cos x by x square. Option 3, f of x equal to cos 1 by x. Option 4, f of x equal to 1 by x. So what is the requirement here? They have given the all these functions are continuous functions on the open interval 0 to infinity. So we have to extend that function to a continuous function on the closed interval 0 to the half to infinity. Okay, so here in this interval the point 0 is included. So to check whether the function is continuous on this half closed interval 0 to infinity, we have to check the limiting value at 0. What is the limiting value of the function at 0? That is, the requirement is here. Limit of f of x as x tends to 0 should be equal to f of 0. So to become a function continuous at a point 0, the function's value at 0 should be equal to the limiting value of the function as x tends to 0. So let us check one by one. So the first function, f of x equal to sine 1 by x. So now limit of f of x as x tends to 0. Here limit of x tends to 0 sine 1 by x. Sine 1 by x. What about this? For this let us check. Put h is equal to 1 by x. Then the limit will changes to limit h tends to infinity of sine h. Okay, so limit changes to this. So this cannot exist. This limit does not exist. Why? As h becomes very bigger, h becomes very large, the sine function fluctuates between minus 1 and 1. So limit does not exist. Okay, hence this function we cannot extend to a continuous function on this interval. Okay, similarly the third question, the function f of x cos 1 by x, also f of x equal to 1 by x, we cannot extend because the limit extending to 0 of cos 1 by x and limit extending to 0 of 1 by x does not exist. Okay, so as x tends to 0, 1 by x becomes infinity and cos this is undefined. Also as x tends to 0, here 1 by 0 it is undefined. So these limits does not exist. Now let us go to the option number 2. So what is that option number 2? Option number 2, they have given 1 minus cos x by x square. So whether this limit exists, we will check. limit extending to 0 of 1 minus cos x by x square. If you put directly the value of x here, you will get cos 0 is 1. So 1 minus 1, 0, 0 by 0 form you will get. So for that we will apply the L'Hospital's rule, L'Hopital's rule. So I will apply this. X tends to 0. The derivative of 1 is 0 minus derivative of cos x is minus sin x divided by derivative of 2x is x square, derivative of x square is 2x. So we will get here limit x tending to 0 of sin x by 2x. So here 1 by 2 is constant, we can take it out. So you will get 1 by 2 into limit x tending to 0 of sin x by x. Okay, so what is the value of this limit? Limit extending to 0 of sin x by x equal to 1. So you will get it is the value is half. Since the reason limit extending to 0 of sin x by x equal to 1. Okay, so limit exists, limit of the function 1 minus cos x by x square as x tends to 0 exists, and the value of 1 is 1 by 2. So if you define f of 0 as 1 by 2, then we can extend this function to a continuous function on the closed interval 0 to infinity. So option number 2 is correct. Okay, option number 2 is correct. Thank you friends. Please share and subscribe the channel.